Hi girls, these are the notes for 8.2. I probably won't do 8.3, but for 8.2. So the second derivative is the derivative of the first derivative. As we know, acceleration is the second derivative of displacement. So the notation looks like this. Sometimes it looks like f double dash of x. Sometimes really bad we do that, but this is a bad, not really a good notation. And the other one looks like this. Instead of dy dx, it's d squared y dx squared, which, oh, that's a confusing notation, I know, but you do see it a lot of times, so that you know. So this one or this one's preferable. Okay, so the first example says, determine the second derivative of that. So I go, okay, dy dx, because they want me to make it look like that, equals 4x cubed plus 6x squared minus 8x. And then d squared y dx squared is equal to 12x squared plus 12x minus 8. Okay, easy enough. I like it. Okay, the next one says calculate f double dash of 9. So I have to do first the derivative. So I'm going to rewrite f of x equals 4x to the 5 halves. Make sure you're versed in that. Over 3x squared. I'm going to simplify that because these are like bases, so I can subtract. So 5 halves minus 4 halves is 3x to the 1 half over 3. So it makes it a lot easier. The first derivative is equal to half down the front, so 2x, and then take off 1, negative 1 half, over 3. That's just a constant down there. And then the second derivative, I'll go up here, double dash of x is, you can think of this really as 2/3 x to the negative 1 half if you want. It's the same thing. So I'll take the negative 1 half down. So I'm really doing 2/3 times negative 1 half, and then I'm subtracting 1 from that. So I'm subtracting 2 on 2, so I get negative 3 on 2. So that is negative 1/3 x to the negative 3 on 2. So that's equal to negative 1 over 3 square root of x cubed. That's what that looks like. That negative, put it under, that's the square root, and that's the power. Flower is the power. Now, I'm going to put the 9 in there. And I write it like this. Two of these can come out as 1, 9. And so that's 27. That doesn't make any sense, does it? Let's get rid of that. This is 3 times 3, 3 times. Right there, yeah? So 3 3's out, so I had it right in the first place. So it's 1 over 3 3's come out, so 3 times 3 is 9, times 3 is 27, and then times 3 again out there. So 1 over 27 times 3, and I think that's 81. Okay, negative 1 over 81. Okay, there's the work down there. Hope you go okay.